Welcome back to this channel, the Formulaic approach channel. If you have not subscribed, do want to do that. But today we are going to be solving questions involving differentiation techniques under main test 102. Okay, so I've selected some exam questions. In this first segment, we are going to be taking some 20 questions that I selected, ranging from polynomials and the applications and graphical questions that you might see. So we are going to solve those questions quickly, and then we are going to solve all forms of questions under differentiation, including trig functions, exponential, and logarithmic equations. Even though I'm parametric, even though I've done individual videos on those, I will link them in the description below. So do want to subscribe to the channel and see those videos. Make sure you see this video to the end, because if you don't know anything about differentiation at all, this video is also for you, because I will take it from like the scratch a little bit. I'm going to go down to your level then before we now, begin to skip steps or, just use tricks. Exactly. All right. So let's go on to the first question, which is a very basic question. It says x raised to the power 3 plus minus 5x squared plus 3x minus 7. Okay. So it says that if our function y is equal to x raised to the power 3 minus 5x squared plus 3x minus 7. So what do you do here? So you differentiate, that is, you take dy dx is equal to, what you do is you bring this power here using the power rule. You use 3 to multiply this guy, so it becomes 3x. Then you reduce this by 1, that 3, you reduce it by 1. Then you have 2, all right? Minus here, 2 multiplies this. The same way, you have 10, then x raised to power, this 2 reduced by 1, that will be 1. So since it's 1, we don't need to write it. Then plus, in the same vein, 1 is the power of this x here. So 1 multiplies 3, and you get what? 3. Okay, but x was raised to power 1 before. Once it's reduced by 1, it becomes 0, and x raised to power 0. So what you have now is 3x raised to power 0. Anything raised to power 0 is 1, so 3 times 1 is what? 3. So that's why we have only 3 there. Then for the case of 7, initially 7 was actually with x, but x is raised to power 0 here. So that the same thing happens here. But by the time you bring 0 down here to multiply 7, it becomes 0. 0 times 7 is what? 0. So that is why the derivative of a constant, is 0. Okay? I hope it's capturing. Okay. So this, therefore, is our answer. Then number 2 says that 5x raised to the power 3 minus 5 over x raised to the power 3. All right. Now, in order to solve this question, you have to first bring it, like simplify it to the form that is that you will find it more comfortable to solve with. So what I want to do is I will write this as y equal to 5x raised to the power 3 minus 5x raised to the power minus 3. So if I have 1 over a is the same as a raised to the power minus 1. If I have 1 over a squared is the same as a raised to the power minus 2. Does that make sense? So that is why 5 over x raised to the power 3 here is the same as 5x raised to the power minus 3. So we can now differentiate dy dx will be equal to, this will come down, 15x squared minus, now minus 3 will come down, so we have minus 3 multiplied by 5 x raised to the power, minus 3 will reduce by 1, that will be minus 4. Minus 3 minus 1 is minus 4. So dy dx becomes 15x squared plus times minus times minus is plus. So 3 times 5 is 15, and we have x raised to the power minus 4. So this can go back down. So we have dy dx is equal to 15x squared plus 15 over x raised to the power 4. All right, from initial knowledge of what I said before, that this negative power means is coming from towards the denominator. All right. Number 3 says 5x raised to power 5x plus 2 root x. Now, if you already understand these basic parts, you can already skip the video to this aspect of tangent to the curve, normal to the curve. I guess that's the part that some students have problem with, and with application. So I'll also solve application questions separately, and that'll be in a separate video. Is that okay? Because the video will be too long if I have to do all the techniques of differentiation with applications. Okay. All right. So I have my y function is equal to 5x plus 2 root x. So by the time I differentiate, so I can rewrite this root x. Root x is the same as x raised to the power 1 over 2, okay? So that dy dx will now be equal to, so I'll now write this as 1 over 2, x raised to the power 1 over 2. So that dy dx will be equal to, by the time I differentiate this, I get constant plus 1 over 2 will come forward, so 1 over 2 times x raised to the power, by the way, dot here means times, okay, 1 over 2 minus 1, you subtract 1 from half, you get negative half, right? So I can just write minus half here. Does that make sense? So I have dy dx will be equal to 5 plus 2 takes care of 2, and then I have x raised to the power minus 1 over 2. So this minus 1 over 2 means that this one is going to go back to the denominator. So we have dy dx will become 5 plus 1 over x, all raised to the power 1 over 2. Okay, then I can rewrite this as dy dx equals to 5 plus 1 over root x. Okay, you can make this into a singular fraction if you wanted, so you just take LCM and all of that, but I want to leave it this way. Is that clear? All right. So that's going to be number 3 answer. And number 4 says that 2x, or into brackets, x plus 3. Okay. Now, when you have a function like this, that y is equal to 2x bracket x plus 3. Okay. Now, you might think that you might want to use product rule to differentiate this, but you know, it's okay, let me use both methods to differentiate so that you see how to do both product rule and simple power rule. Exactly. So look at this. What I'll just do to use the power rule is to open the bracket so that y becomes 2x squared plus this times this, that is 6x, so that dy dx will be equal to 4x plus 6, and that will be my answer. Or if I wanted to now use the product rule, since my y is 2x plus 3 into bracket x plus 3, this will be multiplying this. Remember that product rule says that dy dx is equal to v du dx plus u dv dx. So if that's the case, this will be our u, this will be our v, so you can, it's commutative, so either way you write it. So dy dx therefore will be equal to v, let me make this my v that way. So I will hold this and differentiate this. If I hold this, I will have 2x multiplied by, I differentiate x plus 3, differentiate x, I get 1, constant 0, so 2x times 1 plus, I will now hold this, x plus 3, and differentiate this, differentiate 2x to get 2, so the answer becomes dy dx equals 2x, 2x times 1 is 2x, plus, this opens the bracket to give us 2x plus, this times is 6, so dy dx is equal to 2x plus 2x is 4x plus 6. It's the same as this. So you see, this approach is faster rather than use product rule, okay? So for polynomial expressions, always check if you can use, before you jump to using product rule, you see you can simplify the expression or expand it. Try it before using product rule, okay? The next one now says this. This is another typical question like that will prompt a student to use quotient rule in this case, okay? So if you want to use quotient rule here, now it will take your time, to waste your time. So what you should just do directly is you should use this guy to divide the two expression, or more like split this fraction. so that you have y equal to 2x squared over x plus 4x over x. I hope this is clear. So you now say this divides this divides this, and it remains 1. So y will equal to 2x plus 4, okay? 2x plus 4. So from here we can take dy dx will be equal to, differentiate this now, you get 2. And it's as simple as that, okay? So far the questions we've been solving are very simple. We'll soon graduate. So we have y equal to 9x to the 4th minus 3 over x squared. Okay, now look at this. We can use the same approach so that we'll have y will be equal to 9x raised to the power 4 over x squared minus 3 over x squared. So that by the time I cut this, to remain 2 here, right? And here there's nothing to cut. So I'm going to have that y will be equal to 9x raised to the power 2 minus 3. I'll bring this guy up. 3x raised to the power minus 2 in this case. So if that is the case, then dy dx will now become, this multiplies this 18x, remember? Then so reduce this one by 1, remains 1, right? Minus, this multiplies this, so it gives us minus 6, right? Then x raised to the power, this reduces by 1, just minus 1, that will be minus 3. Okay? So that dy dx will now be equal to 18x plus 6x raised to the power minus 3. Okay? So that dy dx will be equal to 18x plus 6 over x raised to the power 3. And that will be the answer. Okay. Let's go to number 7. Number 7 says that y is equal to 4x squared into bracket 4 minus root x. Into bracket 4 minus root x. So if you want to differentiate this, you can try to open the bracket, but if you open the bracket here, either ways, let's try and open the bracket and see what will happen. So y will be equal to, if you open the bracket, you have 12x squared here, then minus 4x squared times root x will give you 4x squared root x. I'm going to simplify this so that y will now become 12x squared minus, remember that x root x is equal to x raised to the power 1 over 2. So if this is the case, then we can have that 4x squared is multiplying x raised to the power 1 over 2, right? So we have 4x, multiplication of base will lead to addition of power, raised to the power 2 over 1 over 2, which is 4x raised to the power what? 5 over 2. Is this clear? So I can say that 4x raised to the power 5 over 2 here. I hope that is clear. So dy dx is equal to, you multiply this and you get 24x minus, this multiplies this, we have 5 over 2 by 4, then x raised to the power 5 over 2 minus 1, okay? So we have dy dx will be equal to 24x minus, this takes care of this to have 2. So we have 10x raised to the power, this is just 2.5 minus 1, that will be what, 1.5, which will be 3 over 2. Is that clear? So raised to the power 3 over 2. So either way you want to write it, you can either leave the answer like this or say dy dx is equal to 24x minus 10 root x cubed. Okay? So either way you want to leave the answer, you are correct. Then number 8 says that y is equal to 1 over x squared plus 1 over 3x cubed. Okay? If you want to solve this, you have, so you can write y equal to x raised to the power minus 2 plus 3x raised to power. Now, here, everything will be raised to power. Now, this will be raised to power 3, but everything will be raised to power minus 1. Okay? So that when we take dy dx here, to give us this, we multiply this, will give us minus 2, x raised to power minus 3, plus here, let's differentiate this inner function. Okay, this is x raised to power 3. Let's differentiate this inner function. This will give us 3x squared, right? That's for this inner function. 9 rather. 9x squared, 3 times 3, that's 9x squared. Then we'll differentiate the outside function. That will be minus 1 will multiply, minus 1 will multiply this, we'll multiply this, we'll multiply 3x raised to power 3x raised to power 3. Then it will reduce by 1. Or raised to power minus 2. I hope this is clear. Okay? I'm going to use another method to show you so that, in case you're confused. So that we'll have here, we'll have dy dx to be equal to minus 2 x raised to power minus 3 plus plus times minus will give us minus, right? That will be minus 9x squared over, now you know that this entire thing will mean 1 over this entire thing, this place here, this 3x cubed all raised to power minus 2 means 1 over 3x cubed all squared, right? Okay, so I'll say over 3x cubed all squared. Okay, so if that be the case, then what we have is minus 2x raised to power minus 3 dy dx will be equal to this. Now this will be over x cubed, right? Minus, so here we have 9x squared over, if you square this, it will give you 9, square this, x raised to power 6. I hope that's clear. Okay, so 9 takes care of 9, and this takes care of this, remains 4. Okay, so that we have dy dx will be equal to minus 2 over x cubed. Okay, then minus 1 over x raised to power 4, and that becomes your answer. Okay, all right. So let's go to the next question. Question 9 says that we should take the square root of 3x squared plus 2x plus 1. All right, what you want to do is rewrite this as y equal to 3x squared plus 2x plus 1 all raised to power. I told you square root of something means that thing raised to power half, right? If that be the case, then this one will now differentiate the outside function. So this one will come forward and have y equal to 1 over 2 multiplied by 3x squared plus 2x plus 1. Then we'll now differentiate the inner function. So let's differentiate the inner function. The inner function, this, I'm using chain rule, exactly. If I made this equal to u, I'll first find dy du, right? So that dy du will be 1 over 2 times u, right? Raised to power half, minus half. Does that make sense now? So it's the same thing I'm doing here. So I differentiate the outside function, and that gives me this. This will come down to multiply this, then I'll reduce this by 1, and it gives me this. Then I will now differentiate the inner function. I'll multiply this by the derivative of the inner function. Derivative of the inner function is 3x squared plus, derivative of the inner function with this multiplies this will give me 6x, then 6x raised to power 1 plus 2. That's the inner function. Okay, so that we can have dy, sorry, this is dy dx now, right? So that we now have dy dx will be equal to, now, 1 over 2 multiplied by, this entire thing means 1 over, because it's negative, 1 over is the square root of 3x squared plus 2x plus 1, okay? Okay, then multiplied by 6x plus 2, okay? All right, so what you want to do, let's bring this up. Let's bring it up here. So dy dx becomes, now watch this. I can factor out 2 here. If I factor out 2, I'll have 2 into bracket 3x plus 2. 3x plus 1 rather, plus 1, right? Because 1 times 1 times this will give me that. All over 2 root this, root 3x squared plus 2x plus 1. Then 2 takes care of 2. Is that clear? So if that happens, then dy dx will be equal to 3x plus 1 over the square root of 3x squared plus 2x plus 1. And that will be the answer. Okay? So let's go to the next one. Now, if you need more questions like this on polynomial, I have that series of past questions like that on the topic, so that you can reach out to me and then I'll send it to you. You can reach out to me on WhatsApp. Here's my WhatsApp number: 09021416307. Okay, so here number 10 now says, number 10 we have 2y equal to 2 over 3 root 6x plus 5. Okay, so if you want to do this, you say, now in this case, what we use is called the quotient rule. Is that clear? The quotient rule. So we've seen 3 rules that we've used so far. Quotient rule. Now, how do you use the quotient rule here? The quotient rule says that dy dx of a quotient is going to be equal to v du dx minus u dv dx over v squared. The way I teach it to my students is, say, you know, v is the one at the bottom. Okay, the form of this is for y equal to u over v. Okay, so v is the one at the bottom. Just think of it as the larger one is at the bottom. V comes after u, so v is bigger than u. Think of it that way. So small one is at the top, bottom, bigger one is at the bottom. So what you now say is this. What I say is bottom the top, that is bottom du, bottom the top minus top the bottom over bottom squared. Bottom the top minus top the bottom over bottom squared. Okay, and another way in which I write this is vu prime minus uv prime over v squared. Either way you write it, you're saying the same thing. Okay, so using the technique, we'll have that our dy dx will be equal to, so we'll take the bottom now, this bottom, which is 3 root 6x plus 5. Then we'll differentiate the top. When you differentiate a constant, what do you get? 0. Okay? Minus, we will now take the top, that is 2, and differentiate the bottom. Okay, so let me bring it down here. So since you know everything here will give us 0, we will multiply. Let's just use this. We'll just start with minus. Okay, because this thing times 0 will give us 0. And then if you have seen, if you have stayed until now in this video, do have to subscribe to the channel. Is that okay? Okay, if not for anything, for my duster being the biggest on the internet. Alright, so we have so I said we'll start from minus 2, we'll hold the top, then the bottom, we'll differentiate the bottom. So multiplied by derivative of this. Okay, now what you want to do is this, we can express this as derivative of this dx, d3 into bracket 6x plus 5 all raised to power 1 over 2. Does this make sense now? Then all over v squared. What's my v squared? This guy squared. That will be 3 root 6x plus 5 all squared. So let me take the numerator first. Okay, that's how I like to do my work. I want to make it simpler by taking the numerator alone. Okay, so the numerator I will have minus 2, then multiplied by. So let me differentiate this. How do we do that? We can differentiate the inside function first. The inner function will be, derivative of the inner function will be what? 6, okay? Then multiplied by this 3, dot 3, then dot, we'll now differentiate the outside function. The outside function will be 1 over 2, so multiply by 1 over 2, then times this function again, plus 5, then we'll now subtract 1, that will be minus 1 over 2. Is it clear? So here's my numerator. I'm still, simplifying the numerator. I'm still evaluating the numerator. So I have minus 2. Okay, from here, 2 can take care of 2, right? So if that's the case, 6 times this, we have 18 into bracket 6x plus 5 all raised to power minus half. By the time you work this, you're going to have numerator becomes 18 over the square root of 6x plus 5. I hope this is clear. So we'll now include it with the denominator now. By the time we bring in the denominator, becomes numerator over denominator becomes, our numerator is now 18 over the square root of 6x plus 5, okay? Then all over our denominator is this guy, 3 roots, that's all squared. So that will be 3 roots 6x plus 5, everything squared, okay? So what we simply do is just merge these denominators so that we'll have 18 over root 6x plus 5 multiplied by 3. Now if you square 3, you have 9, then times root. This thing squared will take care of the power of the square root, right? So you have into bracket 6x plus 5. Does this make sense? So from here, in fact, you can cut here 1, here 2. So you have 2 over 6x plus 5 into bracket, or 6x plus 5, yes, into bracket root 6x plus 5. And that will be your answer. Or no, you might, since they are the same, you might express them so that this one will be raised to power half, right? So you have 6x plus 5 all raised to power 1 plus half, that's 3 over 2, in which case will be 2 over dy dx will be equal to 2 over the square root of 6x plus 5 all raised to power 3. And I hope this is clear. Okay, let's go to the next one. Okay, let me just write this down. You try this, and we'll go to the ones that have to do with, you try these two and put your answer in the comment section, or you can text me your answer in the WhatsApp, in my WhatsApp number, so that I will, that's my WhatsApp number there, so that I will let you know if you are correct or not. Okay, so we'll have, so do this. That will be number 11 and number 12. So do this. 6x over the square root of 1 minus x squared, and here 2 minus root x over root x plus 3. Okay, so these are the ones we should attempt these two, whilst I'll clean the board now to write application questions on the board. Okay, so let's solve these questions. It says given the curve y equal to 4x raised to the power 3, 4x raised to the power 3 minus 1, find the gradient of the curve when x is equal to minus 2 over 3. Now, one thing you first want to know are the following. First, keep in mind that to answer questions like this, you must know the equation of gradients. Okay, so first, equations of line are represented by you have about three different ways, three different equations. Okay, so we have the one that has to do with just the gradient and intercept. So y equal to mx plus c. That is, if you don't know this, I'll link a video in the description so that you can watch that video. It takes you from beginning to this point. Okay, all right. So y equal to mx plus c. You also have that gradient and 1 point method. So if you are given 1 point, it becomes y minus y1 is equal to m into bracket x minus x1 m plus c. Is it clear? So, or either ways, by the time you work this out, your c will come out. Is it clear? By itself sometimes. Okay. So gradient and 1 point method. So you don't have plus c. 2 point method, that will be y2 minus y1 over x2 minus x1 is equal to y minus y1 over x minus x1. So these are the three forms of the equation. Okay, so you must know these three equations. So whenever you are given an equation of a line, you should convert it to the simplest form, which is this. That's the gradient and intercept method. Okay, so the other thing you have to know is that if two lines are parallel when both of them have the same gradient. If you look at it, look, if I put a Cartesian, my Cartesian coordinate here, you see that the slope are alike. Is that okay? So it means that the gradient of one should be equal to the gradient of the other. So m1 will be equal to the gradient of m2. But if two lines are perpendicular, so still using this my coordinate system, I have two lines, one like this, and the other is perpendicular to it. You don't have to touch before they are perpendicular. Look at the orientation, you see that they are perpendicular. Does that make sense? So this is 90 gradient. So like I call this one gradient m1 and I call the gradient of this m2. The relationship between them is that I've proven it in that video too. So do well to see that video. I will link it in the description. The gradient m1 is equal to negative inverse of m2. That's very common. The gradient m1 is equal to the negative inverse of gradient m2. Okay, so m2 also we got to negative inverse of m1. Either way you put it. So you must know these two. All right. Know those two equations I gave you for parallel and perpendicular lines. So another word they use for perpendicular lines is normal. Okay, so when you say normal to a tangent, so a tangent first is if I have my curve like this and I have a tangent here. Tangent is the line that touches this curve at one point. I could draw my tangent. Why is it not touching now? No. This is secant. Secant cuts through. Is that clear? Secant is the line that cuts through your curve. What tangent is the line that touches at one point. You see? I did that. Now, a normal to this tangent will be a line that is perpendicular to our tangent. Is it clear? So, to our tangent, line that is perpendicular to it. So, what that means is that at this point here, we are going to have the gradient. If this was m1 and m2, then the relationship will hold that m1 is equal to 1 over m2. Is it clear? Still talking about the same thing. Is that clear? So, here, given this curve that is given by this formula, equation y equal to 4x cubed minus 1 over x. Find the gradient of that curve when x equals this. So let's first find the gradient, that's dy dx. So we want to find dy dx. Okay, so one thing I will do is to divide through first by this x. So I'll have the 4x over 3, 4x over 3 over x minus 1 over x, okay? Then I have dy dx will be equal to, this will give me, so I have the 4x squared minus x is by minus 1 dx. So that I have dy dx will be equal to, I differentiate this, I have 8x, minus comes down, becomes minus and minus plus 1, that is x is to the power minus 2. So my dy dx is equal to 8x plus x plus 1 over x squared. Alright, so this is my dy dx. It now says that find the gradient when x is minus 1 over 2. So dy dx will be what? What will be the gradient? What will be the slope of the line of that curve at that point? Or the slope of the tangent to the curve at the point where x. So what will be the slope of the tangent to this curve at this point? If this was the point where on x-axis, x is actually minus 2 over 3. That's what it's asking, is that clear? So that will be 8 into bracket minus 2 over 3 plus 1 over x squared. That will be minus 2 over 3 whole squared. That will be, this by this, that will be minus 16 over 3 plus 1 over, you square this, you get 4 over 9. Okay? So that one will go up. And we'll have dy dx will be equal to minus 16 over 3 plus, this guy will go up, right? 9 over 4. If you don't understand what I did, all I did was, if you divide, look, if I have a divided by, if I divide a whole number by a fraction, say b over c, c will go up to become ca over b, or ac over b. But if I divide a fraction by a whole number, what will happen is a will become, it will become a over bc. Is it clear? Just bring this one down. But with this fraction, you are dividing whole number by fraction. The denominator of the fraction will go up. So that's what I did here. I'm dividing whole number by fraction, so this one went up. So this will become, the whole same of this and this is 12, 4 by this minus 32. So I can just do minus 32 here. And 4 times that, sorry, 64. Minus 64 here. Then the LCM of this, 4 in this, 3 by that, 36. I hope you understand what I did. 3 times, that's 27, sorry. What I did was to interchange, is that correct? This guy is this, so I want it to be positive before negative. Is that correct? Okay, so we have dy dx will be equal to minus 27 plus 27 minus 64 will be 37. So the negative 37 over 12. Okay? Negative 37 over 12. Okay. Okay, so I'm just verifying. This and this. 3 by this. This is yes. Okay, so we have negative that. This is the value of our dy dx. So we have answered question A. Question B now says, we should find the coordinates of the points where the tangent is horizontal. We should find the coordinates of that point where this our tangent is horizontal. Let's be sure we didn't make any mistake here. Okay. So find the coordinates of the points where the tangent is horizontal. Where the tangent is horizontal on a curve, let's say we have our curve like this. So, and this is my Cartesian coordinate. You see, I already drew the tangent there. So this is where the tangent will be horizontal. So at this point where the tangent is horizontal, dy dx will be what? 0, because there's no change there. Okay? There's no change in x there. So dy dx therefore, so at horizontal, dy dx will be 0. Is that correct? That's B I'm solving now. Dy dx will be equal to 0. And what's our dy dx? This guy, right? So we have 8. So 0 will be equal to 8x plus 1 over x squared. Let's multiply through by x squared. We'll have 0 equal to, multiply this by x squared, we will get x cubed plus, multiply this guy by x squared, you get 1. Okay? So you can, so that this guy will go there, we'll have minus 1 equal to 8x cubed. By the time you divide, you have divide both sides by 8, you have x cubed is equal to negative 1 over 8. You now take cube root of both sides. Cube cancel cube root so that x will be equal to minus 1 over 2. Okay, so we are asked to find the coordinates. So x will be 1 minus 1 over 2 at that point. What will y be? What we'll simply do is go and substitute this guy into our original equation to get what y value will be. So recall that y is equal to 4x cubed minus 1 over x. Okay, we simplified these in fact to this. Do you remember? So our y is actually equal to 4x squared minus x raised to the power 1. Okay, we have simplified it. So x at x equals minus half, y will be equal to 4 into bracket minus half all squared. That is us substituting this guy into the equation to get y. Minus, this will be minus half all raised to the power minus 1. Okay? Because of the plenty minuses, don't be confused, eh? This squared will give us 1 over 4, right? 1 over 4 times 4 is 1. Because negative will be positive when you square it, okay? Then here, minus times minus, plus, okay? Now look at this guy. If I, do my magic here, inverse of this will be 2 over 1, right? So this will be 2. So y will be equal to what? 3. So the point where blah, 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 blah is horizontal, our xy points, pxy will be equal to x, that is minus 1 over 2 and 3. And that will be the answer. Okay, so that's just the first one we have solved. Let's go to the second one. If you do not get that one, you can just keep following. You're going to get the second one. Now look at the second one. It says, find the value of h for which the line this, our line, equation of our line, equation of line, this line is a normal. Okay, so our equation of normal, exactly, or equation of perpendicular to the horizon, to the curve. If it's said that it's normal to the curve or perpendicular to the curve, it's the same as saying it is normal to the tangent to the curve. Does that make sense? So that, like, you know, it's mouthful. Sometimes you might be confused. Students are usually confused. Well, I will just get that. So so perpendicular, equation of the perpendicular to the curve is given by 4y minus x is equal to 2h. So let's write it in the standard way. The standard way is that, recall that the standard way is y equal to nx plus c, where n is your gradient. So let's write it that way, such that 4y will now be equal to 2h plus x. Then divide both sides by 4, or divide through by 4. Y will now be equal to, here 1, here 2. That will be h over 2 plus x over 4. So with this, the coefficient of our x is going to be our gradient. So what's the coefficient of x? We should rearrange it, in fact. Y equal to x over 4 plus h over 2. It doesn't affect here because it's positive. So our gradient is equal to 1 over 4. Okay? So the gradient of that line is 1 over 4. And it says that the value of h for which this guy will be a normal to this curve. What that means that this line will be perpendicular to the tangent of this. So let's find the gradient of this tangent. So that we equate the gradient of this tangent, the equation of the tangent to this, the equation of the slope of the tangent rather to the slope of this guy. Does that make sense? Do you understand now? First, let's take the slope of this guy. Recall that our equation is y over 1 over 4 into bracket 1 minus x all raised to power 2. By the time you differentiate this, you use quotient rule. Okay? We use quotient rule. If you want to use quotient rule, actually you can even use, let's use quotient rule. So we have y dy dx. Now you know that dy dx, you know that this one, if I hold this, if I differentiate this, if I hold, let's hold this, that'll be 1 dot, we differentiate, it's supposed to be hold the bottom first rather. So if I hold the bottom and differentiate the top, I'll get 0 ahead. That's what I was getting at. So it means that I'll just have minus, which is the other part of it. Do you understand now? The other part. So that will be minus, I'm going to hold this now, hold the top and differentiate the bottom. To differentiate the bottom, I'm going to have 4 dot 2 into bracket 1 minus x raised to power 1 dot differentiate the inner function to give you minus 1. Okay? All over the bottom squared. So what's the bottom? 4 into bracket 1 minus x over 2 all squared. Exactly. Right. So with this, dy dx will now be equal to what? Minus, if you look at this, minus is going to times minus, right? Wait. Don't look, yes. Let's multiply, so it will be positive here already. So that will be 2 times this. That will be 8 into bracket 1 minus x all over 4 into bracket, 4 squared now, 4 squared. This 4 is squared. That will be 16 into bracket 1 minus x all squared. Sorry, all raised to the power 4, 2 times 2. Is it clear? So if that's the case, here 1, here 2, here 1, here it will remain 3. Does that make sense? Because it's just about 4. So that dy dx will now be equal to 1, dy dx will now be equal to 1 over 2 into bracket 1 minus x raised to power 3, all raised to power 3. Okay? So that is dy dx. What are we asked to do with dy dx? So, if this is our dy dx, our derivative, then it says that find the value of h for which this is a normal to this curve. A normal to this curve. Okay? Now, if we want to find okay, yes. You know that this is the slope of this curve, of this line rather. This line that is normal, okay? So this slope, remember that I said that m1 is equal to negative over 1 over m2, right? So if our slope here is m1, this is also slope, you know, right? This would be m2. Is it clear? Good. So if that is clear, then it means that our m1, which is 1 over 4, will be equal to negative 1 over this, 1 over 1 over 2 into bracket, 1 over 1 over, okay, 2 into bracket 1 minus x all raised to power 3. So we just invert. So I have 1 over 4 equal to negative 2 into bracket 1 minus x all raised to power 3. I hope this is clear. What I just did is I took the inverse of this because that will be the case there. Okay, so if I want to do this, I can multiply through by, I can divide through by 2. If I divide through by 2, here I will have, if I divide here by 2, I will have 1 over 8 is equal to minus 1 into bracket 1 minus x all raised to power 3. So from here, I can take cube root of both sides. No, divide through by minus 2 actually. So a minus will come here. Is that clear? So if I now take cube root of both sides, I will have this. This will cancel this so that we'll have the cube root of negative 1 over 8 will be negative 1 over 2 equal to 1 minus x. So by the time I interchange, x will be equal to 1 plus 1 over 2. So that x will be equal to 3 over 2. So it now says that, okay, so we have found the value of, have we found the value of y? No. Okay, the question is only long, it's not hard, okay? So we have found the value of x. Let's now find the value of y. What is our function? Our function is this. So let's substitute this into the equation. Okay, so let's bring this guy up. So recall that we got x to be 3 over 2. So I recall that our function is 1 over 4, did we simplify it now? 4 into bracket 1 minus x all squared. So y will now be equal to 1 over 4 into bracket 1 minus, what is our x? 3 over 2. So 1 over 1 over 2, right? So 1 cancel 1 squared. So y equal to 1 over 4 into brackets 1 minus this will give you minus 1 over 2 all squared. 1 over 2 all squared is the same as minus 1 over 2 all squared. So which is 1 over 4, right? So y will now be equal to 1 over 4 times 1 over 4. This is, it takes care of it. So y equal to 1 over 1. So y equal to 1. Okay? Alright, let's be sure we didn't make any mistake. This will be this squared negative, and because sometimes if it's this switch, you might think you are correct. This squared is this. Okay, I mean this squared rather 1 over 4, yeah. First, if you subtract 1.5 from 1, you get minus half, right? Yes. So minus half squared 4, yeah. And everything is squared here, yes, yes. So we are correct. So it means our y is 1. So we'll now substitute into that equation. So let's substitute into the equation. The equation says 4y to get h, we just make h subject. Okay, 4y minus x is equal to 2h. So x we got to be 3 over 2. Yes, x is 3 over 2. So we have 4 into bracket 1 minus 3 over 2 is equal to 2h. So 4 minus 3 over 2 is equal to 2h. That's just saying 4 minus 1.5. That will be 2.5, right? If you don't understand what I'm doing, just take us here, the 2 here. This will be 8 minus 3. That's 5 over 2. Do you see that? So I'm correct. So 2.5, which is 5 over 2, is equal to 2h. So simply divide through by 2, and you have over 2 over 2. So if you divide this guy by 2, you will get h is equal to 5 over 4, or 1 over 1 over 4. So that is the value of h. All right, let's solve the next one, which says find the equation of the tangent to the curve. Find the equation of the tangent to the curve. So we have this. Let's first differentiate, okay? Because of tiredness, the other parts, derivative of trig and this thing, we'll do it later. Exactly. I even need to take a water break. You can as well join me. Find the equation of the tangent to the curve y equal to this. Okay? So y is equal to 2x squared minus 3x. That's our equation. When you see things like this, first differentiate your main equation. Is that clear? Of course, you should understand. Is that clear? And that's why I'm trying to explain as much as possible. So that's the derivative there. So this derivative stands for the slope of the tangent. Is that clear? So find the equation of the tangent to the curve. So the slope of that tangent is already this, which is perpendicular to this line. What is the line? Our line is given, line equation is given as 2y minus 4x equals 3. So express this in the correct form. It will become 2y equals, let's shift this guy, so it becomes 4x plus 3. Okay? We now divide through by 2 over 2 over 2, so y will be equal to 2x plus 3 over 2. So the gradient of this our line actually, that is perpendicular to that guy, gradient of M1 is 2. This guy, mx, it already looks like our original basic equation of line. So M1 is 2, and it says that it is perpendicular to this line. So recall that so the gradient of that guy, we should find the equation of the tangent, right? Okay, the equation of the tangent. We found the slope of this tangent. So this slope, 4x minus 3, will be equal to the negative inverse of this. Does that make sense? Either way you write it, whether you say 2 is equal to negative inverse of this, or you say this is equal to negative inverse of 2, you are correct. Is that clear? That because this is slope and this is slope, and they said the two lines are what? Perpendicular. So you multiply 2 by 2, you will get 8x minus 6 is equal to minus 1. So you have 8x is equal to minus 1 plus 6. So you have 8x is equal to minus, it's equal to 5. So by 8 over 8, x is equal to 5 over 8. All right. So with that, we have the value of our x. You remember we are looking for the equation of tangent. So we need to find y. Okay, we need to find y. What will be our y at this guy? We will go and substitute the value for x into the original equation. And what is the original equation? Y equal to 2x squared plus 3x. So y will be equal to, okay, it's the equation of the tangent we are looking for. This is the equation of the line we are given. So don't be confused. Don't come and substitute here. This is the equation of tangent of the line we are given. This is the equation of our curve. So substitute into the curve. So 2 into brackets, this squared, 5 over 8 squared plus, be sure you didn't make mistake 2, this, minus, plus, yes. So 3 into bracket 5 over 8. So we have y will be equal to this square 25 times 2, 50. Okay, this takes care, so we have 4. So we have 25 over 4 plus 15 over 8. By the time you work this out, LCM is 8, 2 by that, 50 plus 8 in 8, 15. So you have 65 over 8. It's getting ugly. Oh, sorry, this is even minus. This is minus. So you have to be careful. Let's even be sure we didn't make mistake here. Okay, this one is correct. This one is also correct. Yes. So sorry, this is minus. Y equal to 25 over 4 minus 15 over 8. So LCM is still 8. 50 minus 15 this time. Either way, let's just do that. Since we did not make any mistake, let's be sure. Okay, 50 minus that will give us 35 over 8. Okay, these are y. And if I made a mistake, please do well to notify me in the comment section. Oh, yes, I'm correct this time. So y will be equal to 35 over 8. And x is 5 over 8. So what do we have to find? The equation of the tangent, right? So the equation we'll now use to find the equation of tangent is gradient and 1 point method, because we have 1 point here. Do well to see the end of this video, because I'm going to solve one question on graph. Is that okay? There's one graph that I saw, okay, with this plenty questions there. So that will be the last, or second to the last question, or third to the last, and we'll do it, we'll share it, exactly. We'll share it. So the equation of the tangent, remember that we have this equation, y minus y1 is equal to mx, m into bracket x minus x1. So this is what we use. We have 1 point, which is 35 minus this. So y minus 35 over 8 is equal to m into bracket x minus 5 over 8. So you now have, so what do you do here? What you will do is, you will now say, you will multiply through by 8. So we have 8y is equal to 8y minus 35 is equal to n 8nx. By the time I multiply everything here, minus 5m. I hope this is clear. So from here, oh, do we have m? Yes, we have m now. What's the gradient of the tangent? The gradient of the tangent is inverse of the gradient of the line. So that will be minus 1 over 2. Sorry, I'll also substitute that in. So let me just substitute that in here. 1. Okay, let me just recall that n is minus 1 over 2 from what we did. Okay, so that 8y minus 35 will be equal to 8 into bracket minus 1 over 2 times x minus 5 in bracket minus 1 over 2. So we have 8y minus 35 is equal to here 1, here 4. Okay, so plus 5 over 2. So we have 4x minus 4x plus 5 over 2. Multiply through by 2 again. So you have 16y minus 70 is equal to minus 8x plus 5. Alright, so you can now write this as 16y is equal to, let's bring this guy here, minus 8x minus, that's plus 75. Okay, and you can now divide through by 16 over 16 over 16 over 16. So y will be equal to 1 over 2, right? Minus 1 over 2x plus 75 over 16. So now this will be the equation of the tangent. All right, let's solve number 16. Number 16 says, given the curve xy is equal to 18, find the equation of the normal at the point 6, 3. So we have our curve is xy equals 18. Okay, then xy is 18. So let's find the y dx there. First, y will now be equal to what? If xy is 18, y will be equal to 18 over x. So that the y dx will be equal to, if you integrate this, 1 over x will give you minus 1 over x squared, right? If you integrate 1 over x, differentiate rather, 1 over x, you'll get minus 1 over x squared. So if I put that here, I will just have 18 minus 18 over x squared. Test it. So now find the equation of the normal. So at this point, okay, our points are 6, 3. Okay, and they represent x and y, right? So at this point, the y dx will what? What will the y dx be? The y dx will be minus 18 over, we'll now plug 6, which is the value of x, into it. That will be 36. That will be 1 here, 1, 2, 2 here, 2. So that the y dx is equal to minus 1 over 2. Do you understand what I did here? What I did here was, it says that given this curve, we should find the equation of the normal. To find the equation of the normal, we have to first know the gradient at that point. At which point? Point 6, 3. So at this point, we have this. But this is the equation of the gradient, and this is the actual value of the gradient, minus half. So the answer is to find the equation at that point. So what do? We will now get this is the value of our dy dx, the gradient. So find the equation of the normal at that point. We already have our x and y value now. Okay, so we just the normal will be perpendicular to it. So m1 will be equal to negative m2, so that the m2 here will be equal to negative inverse of this. That will just be positive 2. I hope that makes sense to you. Positive 2, just take the inverse, which will be 2, then make it negative of negative, positive. So we'll now use 1 point method. We already have x and y. So we use gradient and 1 point method. So we have y minus y1 again equal to n into bracket x minus x1. So we'll make the mistake again. M is already what? 2. So y minus, what is our y1? 3. Is it 3? Yes. 3. Yes, the second one is y. Yes, 3. Equal to n, which is 2 into bracket x minus x1, 6. So we have y minus 3 into bracket 2x minus 12. So y equal to 2x minus 12 plus 3. So that y will be equal to 2x minus 9. And that will be the equation of the normal. Alright, so let's take the last question. And if you stuck to this point, God bless you. Do well to make sure you subscribe to the channel and please share the videos. Let it, go viral. God bless you as you do so. Amen. Okay, this question now says, the diagram shows part of the curve y equal to 2 minus 18 over 2x plus 3, which crosses the axis, the x-axis and y-axis, x-axis, yes, it crosses the x-axis and also the y-axis at P and Q. So it crosses, yes, you can see that this curve, so this is our curve, the equation of our curve, it cuts the x and y-axis at that point. The normal to the curve at this P, at this point P, this normal crosses y-axis at R, okay. Find the equation of the normal PR. So we need the equation of this normal that is perpendicular to our tangent. So first, we need to calculate this position to be able to know the equation of our tangent, right? In our equation of tangent, we have y minus y1 equal to x into bracket m into bracket x minus x1. So we need this to calculate. So to get our equation, we need y1, which will be 0 here. Okay, y1 is 0 here. Okay, y is 0. But x1, we don't know, right? So we have to solve for it. Then m gradient, we don't know also. Gradient, which will be the inverse gradient of our tangent here. So we need the gradient of the tangent. Do you understand now? So this is like the graphical evaluation of all we have been doing so far. So now, let's first find the gradient. We can't find gradient. Anyone is possible. I think it's easier since we know that on x-axis, y here will be 0, right? And recall that we are given y to be equal to 2 minus 18 over 2x plus 3. At x-axis, y will be equal to 0, right? So 0 will be equal to 2 minus 18 over 2x over 3. Let me bring this guy here so that we have 818 over 2x minus 3 is equal to 2. By the time you cross multiply, you will have 18 is equal to 2 into bracket 2x minus 3. I'm used to changing these things. Plus. Alright, so be very careful. 18 equal to 4x plus 6. Okay? So this guy comes here and then we have 4x is equal to this minus this, 12. X equals 3. Okay, so if x, so our coordinates xy is equal to 3, comma, y is 0. Does this make sense? So our point P is this. Is it clear? Our point P lie on coordinates 3, comma, 0. Alright, so we've gotten that. So can we find the equation yet? No, we still need our m, our gradient. So we have to differentiate our function. So recall that our function is y equal to 2 minus 18 over 2x plus 3. So let's differentiate this to give us 0. So y will be equal to 0 minus, to differentiate this, we use quotient rule. Hold the bottom, differentiate the top will give you 0. So 0 again minus, does that make sense? All over, you know that it will give us over 2x plus 3 all squared. So now hold the top, differentiate the bottom. Does that make sense? So 18 dot, differentiate the bottom. What does it give you? Hold the top, hold the top, differentiate the bottom. Differentiate this, you get 2. Right? So you have dy dx now, right? Will be equal to 0 minus 0, that's 0. So dy dx will be equal to minus 36 over 2x plus 3 all squared. Alright, so what do we do? So this is our dy dx, right? That's our dy dx. Now, what are we looking for? We're looking for the gradient. Okay. At that point, we know that x is equal to 3 for what we did. Right? At that point, we know that x is equal to 3. So the gradient at that point is 3. So x is 3. So dy dx, so therefore, the value of that will be minus 36 over 2 times 3 plus 3 all squared. So dy dx will now be equal to minus 36 over 6 plus 3, 9. 9 squared. Sorry. 2 times 3, 6 plus 3, 9. 9 squared is 81. Yes. 81, yeah? So, if 81, therefore, you divide by 9. Here we have 4, here we have 81, 9, right? Okay, so our dy dx will now be equal to minus 4 over 9. Okay, so this is the gradient of the tangent at this point of the curve. Okay, so and you know that if we now to find the gradient of our line, the gradient of our line which is perpendicular to it will be gradient of our line, gradient m2 will be equal to negative inverse of this. That will be 9 over 4. I hope I didn't confuse you. I hope I didn't confuse you. So we have found this. So what are we to find next? We have to find now. We can now find the equation of the line. So I'm going to clean this. So using the above formula, y minus y1. What is y1? Okay, we got our point P to be 3, 0, right? So y1 will be 0. 0 equal to m, the gradient of the line will now be 9 over 4 into bracket into bracket x. Now remember, don't use the gradient of the tangent. Use the gradient of the line here. Okay. So x minus x1. What is x1? We got it to be 3. So multiply through by 4. You have 4y minus 0 is 4y. Then multiply by 9 bracket x minus 3. Okay, so we have 4y equals 9x minus 27. So that y equal to 9x over 4 minus 27 over 4. So this is the equation of the tangent of the normal. Alright, so that's it, normal PR, that's the equation. Then B now says that we should find the coordinates of R. So we should find these coordinates, right? It's very simple. Since we have the line, the equation of the line, we need the coordinates. We already have 1 point, which is 3, right? Want to find the coordinates of R. Okay, you know R is, x will be 0 at R. X will be 0 because it's on the line Y, right? X will be 0. So Y is the one that has value, right? So we need the value of Y. So Y will be equal to 9 into bracket 0. Everything here will give us 0, right? 9 into bracket 0 over 4 minus 27 over 4. This is B. So Y will now be equal to minus 27 over 4. Okay? So our coordinates will be, our coordinates for R will be equal to x in its case will be 0, comma, minus 27 over 4. Or you can put it in whole number form, that is 6 whole number 3 over 4, or 6.75. So then C part now says, find the area of triangle OPQ, OPR rather, OPR, so this triangle, okay? Very simple. What do? You simply take, what is the area of triangle? Formula for area of triangle is what? R base times height. What's our base here? Our base here is this place. So from here to here is what? 3. So that becomes 1 over 2 times 3 times height from here to here. What's our height? That's our y value. That's this guy. Times negative 27 over 4. Okay? Well, the negative doesn't really do anything, so we can just remove it. Is it clear? Even so, our x is supposed to be positive. This is supposed to be positive because y is on the positive side. By the time you solve this, 23 times 3, 27 times 3, that's 81. So you have 81 over 16 units, was it units squared, exactly. So this is going to be the answer for the area, provided we didn't make a mistake around here. Alright, do well to subscribe to the channel and click the bell notification to get notified whenever I drop a new video. God bless you.